Scotland's landscape is carved by ancient faults. And we're going to look at one of them, the Highland boundary fault, and we'll look at it here. So it's off to northeast Scotland. I'm right on the edge of Scotland's Grampian Highlands, a metamorphic interior of a mountain belt, and it ends really abruptly just over here. So that fertile ground down below is the edge of Scotland's central belt, and we're right on the edge of the high ground of the Highlands. And along the foot of the escarpment here lies one of the great structures of Scotland. It's the Highland boundary fault. The fault separates different landscapes and distinct geology. So let's explore it together by doing a traverse out of the central belt rocks into the rocks of the Highland along the coast. So let's get down away from the hills. And the rocks we're starting on are these. This is one of the historically great geological formations of Britain, a succession long known as the Old Red Sandstone. It's detritus that washed off the ancient Caledonian mountain ranges and that accumulated in sedimentary basins adjacent to these mountains. So we can find a modern analogue here in Arabia. The Oman Mountains and a sedimentary basin next door, receiving detritus washed off the mountains. These types of basins are called foreland basins. So the first questions for us are, which mountains sourced the sediment of the Old Red Sandstone? Did this sediment accumulate in the foreland basin? And how do these sediments relate to the Grampian Highlands next door? To understand the fault, like all tectonic geology, we'll need to marshal a bunch of different information from sedimentology, structural geology, and more besides. We'll assemble all of this on a geotraverse from the Old Red Sandstone into the rocks of the Grampian Highlands. And this will take us across the Highland boundary fault. And we'll start off here on the coast at the tiny village of Crawton. It's a bit of a scramble down onto a rocky platform. But what fantastic rocks. Well, these are pretty dramatic boulder beds, and they must have been carried out from nearby mountains by pretty energetic flows. Debris flows washing material out into the basin. The boulders at Crawton are very variable. Granitoids and metamorphosed sandstones. We'll see this rock type later. And these are sourced from the unroofing Grampian Highlands. But there are other class here too that were derived from what's presumed to have been once uplifted land areas within the Middle Valley Basin. So a rather complex tectonic system. And there's another component in these outcrops that challenge the simple foreland basin idea. The cliff at the back of this platform of conglomerates isn't conglomerate. It's an old lava flow, Looking down on its top, we find columnar jointing. These igneous rocks have a so-called intermediate composition. They're trachyandesites, and these are generally taken to be indicative of convergent plate boundaries, though perhaps this geochemical signature was inherited when the region lay above the subduction zone that helped to close the Iapetus Ocean at the end of the Caledonian orogeny.
There's clearly more going on in this basin. It's not just simply a fallen basin. We've got contemporaneous lava flows.
So, a tectonically complex basin. It's not a simple fallen basin that lays south of the Highland boundary fault. So let's go on a traverse towards the fault and start a deformation story. Because down here at Crawton, the old red sandstone is gently dipping. But that's about to change. So let's just check out a little bit further north along the coast. But as you approach Dunnottar Castle, the rocks really steepen up. So, steep conglomerates. We've crossed the axis of a major fold structure, the Strathmore syncline, which runs near parallel to the Highland boundary fault. So here's the Highland boundary fault, here's the Strathmore syncline, steep dips on the northwest side, gentle to the southeast. We can talk more about this a little bit later, but for now we can continue our traverse, which takes us through the town of Stonehaven and its harbour, rebuilt successively over the centuries. This version dates back 200 years. So on around the bay to the village of Cowie. And just as at Dunnottar, the rocks are stood on end. But these aren't conglomerates, but sandstones, a bunch of rocks unsurprisingly called the Cowie Formation.
Well, let's have a look at a couple of the main fascies in here. And we can start off with this. Well, if we scope along the beach here, there are these pretty spectacular, 2-metre thick beige sandstone units. If we look carefully in here, we can find cross-bedding, really nice, heading towards coarse sandstones, really well sorted, almost certainly fluvial channel systems. But there's more in here than just these beige sandstones. There are also these laminated red silt and fine sandstone units, almost certainly deposited on large floodplain areas in times, of flood. So classic components of a fluvial system.
So this is the Cowie Formation, but it has a surprise in store, because detailed work on the sediment grains by my colleague Adrian Hartley and Sophie Lulure couldn't find anything derived from the Grampian Highlands. They argue that at the time of the deposition of the Cowie Formation, the highlands weren't high and weren't shedding class southwards. No, these sediments came from the northeast. So the Cowie Formation is quite unlike the Crawton conglomerates, and collectively they give important information of the geological evolution along this edge of the highlands and the evolution of the Highland boundary fault. So the Cowie Formation is standing on end, but given these steep dips, We should ask about the stratigraphic order here and confirm the only direction in the strata.
Some really nice ripples here that we can use to get the stratigraphic way up.
Looking down on the near vertical bedding, let's orient the view and identify erosional truncations of the lamination in the ripples. So they're eroded towards the top of this view. Younger strata lie towards the southeast.
So these rocks get younger that way, older that way. So let's keep going down section now into what we now know are older rocks, so we can find the basal contact of the old red sandstone.
These are rather difficult rocks. They're breccias and rather heavily weathered. Not the simple sandstones we've just left behind.
Well, when faced with difficult rocks like we've just seen, I find it useful to step back onto familiar ground and work back to the problem. So let's come back over here where we've got the old red sandstone steeply dipping like this. So we can work our way back to presumably the older rocks that are the problem. And I can see that up there, well, that looks to be bedded too. So I'm going to check that out as we work our way back from the old red sandstone back in time. So these rocks are indeed still bedded. They're sort of micro breccias, and we come through this, there's still hints of these bedded siltstone sandstone packages in here, but this lot is just a pile of breccia. So a pile of breccia, very angular clasts in a silty sandy matrix. So this is the basal part of the old red sandstone, and these clasts I can see are dark, they're basalt. So we've got a basaltic source for this material, and maybe that's what we were looking at over there, highly weathered basalt, almost a regolith, a soil profile beneath the old red sandstone, brecciated up as part of a weathering erosional process that eventually will grade out into the old red sandstone. So let's go and find a better segment where we can look at these, hopefully, basalts in a bit more detail.
So we're dropping down below the Cowie Formation and the rest of the old red sandstone to enter a set of rocks known as the Highland Border Complex. For a long time they're a bit of a puzzle, thought to be entirely fault bounded along the Highland Boundary Fault. But as we've seen, they're actually overlain unconformably by the old red sandstone, so at least locally they're the basement to the sedimentary rocks of this part of the Midland Valley Basin that lies south of the Highland boundary. So let's just look at the cross section. We've got the conglomerates at Crawton that dip gently. We then cross the axis of the Strathmore syncline and go into rocks of its steep northwestern limb. Initially conglomerates, but then as we go deeper we see the older sandstones of the Cowie Formation. And these are underlain in turn by the what would be basement of the Highland Border Complex. We've yet to have a look at those rocks, and we'll complete the cross section going further to the northwest later on, once we've located and crossed the Highland Boundary Fault. Right, Let's get back to the Highland border rocks.
So for fairly obvious reasons, these rocks are traditionally called greenstones. Not much genetic in that term, it's purely descriptive. Incidentally, this yellow texture you can see all over the rocks above our high water mark, well, this is lichen. Again, characteristic of these types of rocks. And what they are low-grade metamorphism of basalt. So lots of chlorite epidote in the rock that gives it a green colour. But they're quite sheared and difficult to see the original form of that basalt. But there are reports out on that promontory over there of pillow basalts, evidence for submarine basaltic lava flows. So let's go over there and have a look.
These pillow basalts, they take a bit of looking at. They've got classical bulbous shapes. The pillows, which are actually feeder tubes for submarine basaltic flows, commonly collapse into a basaltic breccia, which is what most of these rocks are.
So yes, indeed, pillow lavas. So submarine lava flows in here. There's another component to the geology in this package of rocks that we can look at just down in the cove down here. So these beige, almost orange weathering rocks, well, there's an awful lot of carbonate in these. These are what some geologists would call ophicalcites, reaction products of seawater with serpentinite. That's hydrated mantle rocks. So perhaps there's an association here between pillow basalts, submarine basaltic lava, and on the same seabed, exposed mantle rocks. Really interesting associations. So these are the rocks of what's known as the Highland border complex. Caught up along, well, the Highland boundary fault, overlain unconformably by the old red sandstone. Well, I've just mentioned it. Where's the Highland boundary fault? It's just on through here. Let's go and find it. So I'm just coming off the rocks of the Highland border complex. These greenstones. Over there, on the far side of the bay, well, those are Dalradian, rocks of the Grampian Highlands.
Unsurprisingly, the wall rocks to the Highland boundary fault are highly fractured. And unfortunately, the fault core itself is covered by modern slope debris. But we can follow on into the Grampian metamorphic rocks.
So these are samites, these are metamorphosed sandstones, part of the Dalradian sequence. Not much to look at, in fact they're pretty shattered. You can still make out, well, just about make out bedding coming down through here. But yeah, these are rocks of the Grampian Highlands, so we've crossed the Highland boundary fault. Hard to pick it out in the back of the bay here. We'll see it further along our traverse when we continue later on. But for now, I'm going to go up to the clifftop path to get a view down across this cove to describe what we've got geologically in this rather beautiful location. So that's the Highland boundary fault. I'm stood here on the Grampian terrain, metamorphosed deformed Dalradian metasedimentary rocks. Over there is the Highland border complex, pillow lavas, submarine basalts, that is, potentially exhumed mantle as well. And then we go off into the basin of the old red sandstone.
We can cross the bay and look back onto the rocks we've just been seeing. The Highland border rocks, the basalts, greenstones, and the serpentinites. And, over on the right, to the northwest, sammites of the Dalradian, the Grampian metamorphics. And between them, the Highland boundary fault, dipping, at about 60 degrees, back beneath the Grampian rocks.
So that's the Highland boundary fault, Highland border complex, going on off towards the town of Stonehaven, where we have the old red sandstone, and to the right we have the Dalradian rocks. Let's continue along, find some more outcrop.
This is Garran Point, and we can have another look at the Highland border rocks. The greenstones here are highly sheared and platy. So these have been sheared up along the Highland boundary fault.
So in the Highland border complex we've got these highly sheared former greenstones, completely phyllenitic now, really platy. They're juxtaposed against these orange rocks down here, which are those carbonate fault zones associated with the serpentinite of the Highland border complex.
It becomes a bit more debatable about how much of this deformation occurs because of the Highland boundary fault and how much is inherited from the old original seafloor and the ophicalcite processes. It's quite a controversial topic, and I'm not going to go into it much further now. Time to move on.
Well, so much for these rocks of the Highland border complex and the Highland boundary fault. Let's go and see what lies beyond the fault, rocks that make up the Grampian Highlands. Well, these rocks here are all a bit covered in black algae from the sea. Let's continue and see if we can find some cleaner rocks. Okay, so that's more like it. Let's have a look at these rocks here. Well, these were once sandstones, they're now what we call sammites. They're metamorphosed. They're a set of rocks known as the Southern Highland group, and they're actually really boring, monotonous series of these sandstones, occasional metashales, peelites, no good marker beds, so it's really hard to work out the structure. Anyway, let's continue along the coast, look at some of the characteristics of this bunch of rocks. So there are places where you can put some of the structural story together, because here we can see that bedding is this steep fabric coming down like this. Schistosity or cleavage is inclined like that. So we have bedding and schistosity. The other feature here is that the bedding here youngs this way if we use the grading. It's pretty subtle, but you can see it if you get really close. So that means that this fold structure is downward facing. It's a critical relationship that was used by Robert Shackleton back in the 1950s to work out the structure of the southern part of the Dalradian succession here in the edge of the Grampian Highlands.
So this is bedding and schistosity. The divergence implies this structure on a larger scale. To the southeast lies a synform, but the stratigraphic younging means this synform is also an anticline, older rocks in the core. The fold is downward facing. These relationships have been used to identify an earlier, perhaps recumbent fold. This speculative early structure has been called the Tainap, and it was refolded, creating the relationships we see here, the so-called Southern Highland downbend. We'll look at this a little more shortly, but let's get back to the Dalradian strata.
Well, actually, these rocks are really quite difficult to interpret structurally. And part of the reason for that is this fabric in here. First glance, you might think it's a depositional lamination, but actually it isn't. It's a deformation fabric, essentially a spaced cleavage or schistosity made by pressure solution within these metamorphosed sandstones. And it can be really difficult to see the original bedding.
So this schistosity is found all over the Southern Highlands, and we've seen these rocks earlier in this film, forming some of the boulders in the Old Red Sandstone, which is evidence for the unroofing of the ancient Grampian mountain belt.
So let's continue on our way up along the coast. So you've got to be a bit careful not to take structures like this at face value, because this fabric you can see folded here isn't bedding, it's a tectonic fabric.
The folded schistosity has this form, a vergence that can be related to our interpretation of a downbend fold.
So these are late folds. They're actually associated with the downbend of all these Dalradian rocks down against the Highland boundary fault.
So it's time to step back and look at the structure of the Southern Highlands in its Grampian context, a metamorphic terrain bounded now by these major late fault zones. The structure, as we know it today, was proposed first by Peter Thomas back in the 1970s and has been modified by others since. This is the Stonehaven section, and the downbent nose of the Tainap. It's a complex and not universally agreed tectonic picture, but it'll serve for us for now.
Okay, well, so much for the deformation here. Let's continue along the coast just to get one last aspect of this Dalradian Grampian Highland geology. So these rocks are pretty deformed and dismembered. You can see bits of fold structure between these sort of semi-palitic layers and samites in here, bits of vein, but it's not really the deformation that's important here, it's the metamorphism. And these rocks contain porphyroblasts of garnet, staurolite and biotite.
These assemblages imply peak temperatures of around 550 degrees centigrade, but it's difficult to get a precise estimate of the pressure these rocks crystallised at, in other words the depth from which they've come from.
So we're well within the metamorphic heart of the Dalradian rocks of the Grampian Highlands here.
But in the heart of the Grampians, though, the temperatures we can infer from the metamorphic assemblages are over 650 degrees centigrade and are marked by migmatites, rocks that experienced partial melting. So, across the Highland boundary fault, we've gone from sedimentary rocks of the Old Red Sandstone that include detritus derived from the unroofed Grampian mountain belt, to the metamorphosed and deformed Dalradian sedimentary rocks of the Grampian Highlands. There remain controversies not just with both of these successions. For example, the contribution of other source areas to the building of the Old Red Sandstone, not to mention its basin dynamics. The structure of the Grampian Highlands remains debated, and the tectonic significance of the Highland border complex may be as a fragment of the Iapetus Ocean that was otherwise subducted at the conclusion of the Caledonian orogenies. But it certainly makes for an interesting transect.
So that's been a look at the geology along and across the Highland boundary fault. I've been Rob Butler. Thank you for watching this short film from the Shear Zone channel.